Half of the available Tesla semi-trucks were snapped up in just 24 hours. It may sound unbelievable, especially for a heavy-duty electric truck that costs close to $300,000, but that's exactly what's happening. According to market analyst Sawyer Merritt, a recent surge in orders wiped out nearly half of the available inventory in just one day. If you're new to the channel, please subscribe and don't forget to press the bell icon. Who would have imagined that a Class 8 electric truck priced between $250,000 and $300,000 could sell so quickly? This overwhelming demand sends a clear message to anyone still unsure about the future of electric trucking. Major logistics companies are no longer waiting to see what happens. They're actively competing to secure some of the very first Tesla semis coming off the production line. The growing demand comes at the perfect time, as Tesla has officially begun mass production of the Semi at Gigafactory, Nevada. Production started on April 29, 2026, with plans to build thousands of trucks before the end of the year. In the long run, Tesla aims to reach an annual production capacity of 50,000 units. Large transportation companies are already placing major orders. One example is Watt EV, which committed around $100 million to purchase 370 Tesla semis in early May, with the first 50 trucks expected to arrive this year. At the same time, California's hybrid and zero-emission truck and bus voucher incentive project reported that 89 different fleets had committed to buying a total of 1,095 trucks by the end of the first quarter. At this stage, it's clear that customer demand isn't Tesla's biggest challenge. The real limitation is how quickly the company can build enough trucks. To meet the performance expectations of commercial fleets, Tesla developed an incredibly large battery pack. Documents filed with the California Air Resources Board show that the standard Tesla Semi comes with a usable battery capacity of 548 kilowatt-hours. The long-range version takes things even further with an impressive 822 kilowatt-hour battery pack. For comparison, a Tesla Model 3 uses a battery of around 64 kilowatt-hours. Thanks to this enormous energy capacity, the long-range Tesla Semi can travel up to 500 miles in real-world driving conditions. When it's time to recharge, Tesla's megawatt-level charging system can restore roughly 60% of that driving range in only 30 minutes, helping reduce downtime during required driver rest breaks. Although the technology is highly advanced, the truck's pricing has changed significantly since it was first introduced. Back in 2017, Tesla estimated the base model would cost around $150,000, while the long-range version was expected to sell for $180,000. However, recent regulatory filings show the current prices have increased to approximately $260,000 for the standard model and $300,000 for the long-range version. Even at those prices, the Tesla Semi holds a unique position in the market. It costs considerably more than a traditional diesel truck, which averages about $172,500, but it's still much more affordable than many competing electric trucks, which can average around $411,000. In states like California, where buyers may qualify for incentives worth up to $120,000, the Tesla Semi can become just as affordable as a diesel truck. Once lower fuel, maintenance, and operating costs are included, the financial case for the Tesla Semi becomes even stronger. Many believe Tesla has the potential to reshape the freight industry in the same way it transformed the passenger vehicle market. But how does the truck perform in the real world? One of the biggest tests came when Covenant Logistics, one of North America's largest freight carriers with more than 2,600 tractors, spent 2 weeks evaluating the Tesla Semi in California. This wasn't a carefully controlled demonstration or a closed-track test. Instead, the company chose one of America's toughest freight routes, the famous Grapevine section of Interstate 5. According to Matt McClelland, Covenant Logistics Vice President of Sustainability and Innovation, the driver was genuinely impressed by the truck's performance. His opinion carried extra weight because experienced truck drivers are often skeptical of new technology, especially when it comes to replacing diesel-powered rigs. However, after spending plenty of time behind the wheel, the driver said he actually felt more confident driving the Tesla Semi than a conventional diesel truck. That single statement should grab the attention of the entire trucking industry. For years, critics have claimed that battery-powered trucks might perform well on flat highways, but would fall short when faced with steep mountain climbs, heavy cargo, and long-distance freight operations. The Grapevine is one of the toughest routes a heavy-duty truck can encounter, making it the perfect place to test those claims. Located along Interstate 5 between Southern California and the San Joaquin Valley, this highway is one of the busiest freight corridors on the West Coast. Every day, countless shipments move through this route, linking the major ports of Los Angeles, Long Beach, and Oakland with distribution centers across California and neighboring states. The biggest challenge begins with the climb. Tejon Pass rises to nearly 4,160 feet above sea level, making it the highest point on California's Y5. Trucks traveling north must haul extremely heavy loads up long, steep grades, where losing speed can quickly become a serious problem. Regaining that momentum on such an incline demands tremendous power. This has always been a weak point for traditional diesel trucks. Even today's advanced diesel tractors often slow down noticeably while pulling heavy cargo uphill. Drivers have to carefully manage gear shifts and engine performance to maintain speed. Once momentum is lost, recovering it can be difficult and time-consuming. The Tesla Semi tackles this challenge in a completely different way. Its three-motor electric drivetrain delivers maximum torque instantly. Unlike diesel engines, which need time to build power and operate best within a certain RPM range, electric motors produce full torque from the moment they start turning. That allows the Semi to continue pulling strongly, even when carrying heavy loads on steep climbs. For drivers, the biggest advantage is consistency. There's no constant shifting or waiting for the engine to respond. Power is available the instant it's needed, helping the truck maintain speed more smoothly and making the overall driving experience far more predictable. However, climbing the mountain is only part of the challenge. The real test begins on the descent. Southbound traffic leaving Tejon Pass must navigate one of the most demanding downhill stretches in American trucking. Over just 11.6 miles, the road drops roughly 2,613 feet. The steepest section, known as the Grapevine Grade, maintains an average slope of around 6% for nearly 5 miles. For diesel truck drivers, this downhill run can be just as challenging as the climb. Many people assume braking is simple, but controlling a fully loaded Class 8 truck on a long mountain descent is one of the most difficult tasks a driver faces. Gravity constantly pulls the truck faster, forcing the braking system to work continuously to keep the vehicle under control. Traditional diesel trucks rely mainly on engine braking and conventional friction brakes. Friction brakes slow the truck by converting its movement into heat. During long downhill descents, that process generates enormous amounts of heat, placing tremendous stress on the braking system. If the brakes become too hot, their stopping power begins to decrease, a condition known as brake fade. This has been a major safety concern in mountain trucking for decades. Experienced drivers know they must constantly monitor speed, choose the correct gear, use engine braking properly, and carefully manage brake pressure throughout the descent. A single mistake can have serious consequences. The Tesla Semi changes this process entirely. Instead of depending mostly on friction brakes, it uses regenerative braking as its primary method of controlling speed while driving downhill. This is much more than a simple efficiency feature. It completely changes how the truck handles mountain descents. As the Semi travels downhill, Its electric motors switch roles and act as generators. Rather than consuming electricity, they produce it. The resistance created by this process naturally slows the truck while sending energy back into the battery. In other words, gravity becomes an advantage instead of a disadvantage. The heavier the load and the steeper the hill, the more energy the truck can recover. Rather than wasting that energy as heat through traditional brakes, the Semi converts much of it back into usable electricity. The safety benefits are equally impressive. Since regenerative braking handles most of the slowing, the conventional friction brakes experience far less wear and significantly lower heat buildup, helping improve both reliability and driver confidence during demanding mountain descents. One of the biggest advantages of Tesla's regenerative braking system is that it keeps brake temperatures much lower. This reduces wear on the braking components, lowers maintenance costs, and greatly minimizes the risk of brake fade. For fleet operators, that means several important benefits at once. The first is improved safety. Drivers have better and more consistent control during long downhill descents. The second is reduced maintenance, since the traditional brakes are used far less often and can last much longer. The third is increased efficiency, because energy that would normally be lost as heat is instead captured and stored back in the battery. It's easy to understand why Covenant Logistics' driver felt so confident behind the wheel. In the trucking industry, confidence isn't built through advertising. It comes from real-world performance. Drivers trust a truck when it delivers reliable power on steep climbs and remains stable and predictable on challenging descents. That's exactly what the Tesla Semi appears to be doing. Even more impressive, Covenant's experience isn't a one-time success story. Since Tesla officially started mass production of the Semi at Gigafactory Nevada on April 29, 2026, several major trucking companies have been carrying out their own real-world evaluations. ArcBest, for example, drove the Tesla Semi for 4,494 miles in just 3 weeks and recorded an average energy consumption of about 1.55 kilowatt-hours per mile during normal freight operations. DHL Supply Chain also completed a 3,000-mile evaluation while hauling fully loaded trailers and achieved roughly 1.72 kilowatt-hours per mile before accepting delivery of its first Tesla Semi. CVA Logistics reported noticeable reductions in emissions during its testing program, while MDB Transportation and ALO Logistics launched pilot projects focused on freight movement around major ports. These results reveal an important shift in the industry's mindset. The conversation is no longer about whether electric trucks are capable of handling real commercial freight. Instead, companies are asking how quickly these trucks can be deployed on a larger scale and how much value they can bring to everyday operations. Perhaps the most important point is that these companies aren't judging the Tesla Semi based on specifications or marketing materials. They're testing it where it truly matters, on busy freight routes with heavy cargo and under demanding real-world conditions. That naturally leads to a bigger question. If the Tesla Semi can win over experienced drivers while operating on some of America's toughest trucking routes, what happens when Tesla begins producing tens of thousands of these trucks every year? Will electric trucks simply become another choice for fleet owners? Or are we witnessing the biggest transformation in freight transportation since diesel engines first took over the industry? Matt Godfrey, president of ABF Freight, explained ArcBest's decision to expand its Tesla Semi fleet by saying that adding more trucks allows the company to test heavy-duty electric vehicles across a wider range of routes and operating conditions to determine whether they can consistently meet the company's standards for safety, reliability, and overall performance. That decision came after thousands of miles of successful real-world testing produced some of the strongest Tesla Semi results seen so far, attracting serious attention throughout the trucking industry. Tesla's manufacturing progress has also become more visible. A factory video released in June 2026 showed 6 newly built Tesla semi-trucks, including 4 standard-range models and 2 long-range versions. The appearance of both configurations suggests Tesla is steadily increasing production while preparing to serve multiple transportation needs, from regional deliveries to long-distance freight operations. Just as impressive as production is the truck's efficiency. During ArcBest's testing program, the Tesla Semi averaged only 1.55 kilowatt-hours of energy per mile across 4,494 miles of commercial hauling. That number may not sound extraordinary to the average person, but for fleet managers, transportation executives, and competing manufacturers, it's a major milestone. Tesla originally targeted an efficiency of around 1.7 kilowatt-hours per mile, making the 1.55 kilowatt-hour result even more remarkable. Earlier fleet trials conducted by DHL and Cisco had already delivered excellent results of approximately 1.72 and 1.73 kilowatt-hours per mile, setting a high industry standard. ArcBest's latest performance improves on those figures by roughly 9%, raising expectations even further. So what explains the improvement? Did Tesla install a larger battery or perform the tests under ideal laboratory conditions? The answer is no. What makes these results so impressive is that they were achieved during real commercial operations. The Tesla Semi wasn't driving around a closed test facility or operating under perfect weather conditions. It was doing exactly what trucking companies expect every day, hauling freight in real-world environments where performance truly matters. During the evaluation period, the Tesla Semi covered a wide variety of real commercial routes. It traveled between Reno and Sacramento, operated throughout the San Francisco Bay Area, supported rail freight operations, and averaged more than 320 miles every day. These are demanding trucking routes where maintaining high efficiency is never easy. One of the biggest reasons behind the Semi's strong performance is its aerodynamic design. Traditional diesel trucks have a boxy shape that creates significant air resistance, especially at highway speeds where aerodynamic drag becomes a major source of energy loss. Tesla took a completely different approach by giving the Semi a sleek front end, smooth body lines, and carefully engineered airflow to reduce drag as much as possible. The payoff is lower energy consumption over long distances, making the truck especially efficient on highway routes where every mile counts. Aerodynamics, however, is only part of the story. Tesla also benefits from designing nearly every major component in-house. Instead of depending on multiple suppliers for motors, batteries, software, and control systems, Tesla develops them as one fully integrated system. This allows the Semi to constantly adjust and optimize energy usage in real time. Whether the truck is accelerating, climbing steep hills, or driving across changing terrain, its software continuously balances performance and efficiency to get the best possible results. Another moment that attracted industry attention came during testing over Donner Pass. ArcBest drivers reported excellent performance while crossing this challenging mountain route, which rises to roughly 7,200 feet above sea level. Donner Pass is well known for its steep grades that place enormous demands on heavy-duty trucks. Diesel-powered vehicles typically burn large amounts of fuel while climbing and then waste much of that energy while descending. The Tesla Semi handles the same challenge much differently. Its regenerative braking system captures energy while traveling downhill and sends it back into the battery, effectively turning mountain descents into an opportunity to recover power instead of losing it. But perhaps the most impressive part of the evaluation wasn't the efficiency numbers. It was the response from the drivers themselves. Fleet operators understand an important reality. If drivers don't enjoy using a truck, that truck won't spend much time on the road. Technical specifications may look impressive, but driver satisfaction ultimately determines whether a vehicle succeeds in daily operations. According to ArcBest, drivers consistently praised the Tesla Semi for its centrally positioned driver's seat, outstanding visibility, easy-to-use controls, and comfortable cabin during long workdays. Other companies have shared similar experiences. Drivers from Covenant Logistics were reportedly impressed by how effortlessly the Semi handled California's challenging grapevine grade, further strengthening confidence in the truck's real-world performance. This naturally raises an important question. If the Tesla Semi costs significantly more than a conventional diesel truck, why are so many fleet operators rushing to place orders? And why did California introduce a new incentive program just as the Tesla Semi entered mass production in 2026? The answer goes far beyond the purchase price. For years, critics argued that the biggest obstacle to electric freight transportation was the higher upfront cost. On the surface, that argument seemed reasonable. With a purchase price of around $290,000, the Tesla Semi is considerably more expensive than many diesel tractors. However, recent financial studies suggest that focusing only on the initial purchase price overlooks the much bigger economic picture. A total cost of ownership analysis published by Electrek, with support from Bernstein Research, found that the Tesla Semi's long-term operating costs are becoming increasingly attractive for commercial fleets. Using a long-range Tesla Semi priced at approximately $290,000, the study estimated that operators could save anywhere between $147,000 and more than $400,000 over 5 to 10 years, compared with a comparable Freightliner Cascadia diesel truck. The exact savings depend on factors such as electricity prices, diesel fuel costs, and operating conditions. Based on electricity costing roughly 12 cents per kilowatt hour and diesel averaging about $5.35 per gallon, the analysis estimated the Tesla Semi's total ownership cost over 10 years at around $795,000. By comparison, a similar diesel truck was estimated to cost nearly $1.2 million over the same period. These numbers help explain why companies like Big F Transport have committed to purchasing dozens of Tesla Semi trucks. Their decision wasn't simply about supporting electric vehicles or the Tesla brand. It was driven by one thing above all else: economics. As the long-term savings continue to grow, the financial case becomes increasingly difficult for fleet operators to ignore. The picture becomes even more compelling when California's incentives are added. On May 13, 2026, the state officially introduced the Clean Commercial Freight Rebate (CCFR) program. The initiative launched with a $250 million budget for 2026 and includes a long-term funding commitment of $1 billion through 2030, providing even greater support for businesses transitioning to zero-emission commercial trucks. Applications for the new incentive program are set to open on June 26, 2026. Almost at the same time, Tesla begins delivering mass-produced semi-trucks from Gigafactory, Nevada. That timing immediately raised an important question. If California already had one of the nation's best-known electric truck incentive programs, HVIP, why introduce another one? The answer becomes clear when looking at what happened between January 2025 and February 2026. During that period, California received 1,067 applications for Class 8 electric truck incentives. Out of those, an incredible 965 applications were for the Tesla Semi. Combined, Daimler, Volvo, and PACCAR accounted for fewer than 100 applications. The difference was so large that state regulators could no longer ignore it. Eventually, the California Air Resources Board removed the manufacturer cap that limited how many incentives a single company could receive. Officials explained that the restriction prevented customers from purchasing the trucks they actually wanted. However, some critics argued that the updated system gave Tesla Semi buyers a significant advantage. Alexander Votes, CEO of Nikola Truck USA, publicly criticized the program, saying that competing manufacturers often had trucks ready for delivery but were placed at a disadvantage because of how incentive funding was distributed. Instead of continuing to adjust to the existing HVIP program, California introduced the Clean Commercial Freight Rebate, or CCFR, as a completely new framework. Unlike HVIP's first-come, first-served approach, CCFR distributes funding based on specific commercial applications, such as port operations, regional freight routes, and urban delivery networks. The Tesla Semi qualifies across most of these categories, making the financial benefits even more attractive. When incentives from both HVIP and CCFR are combined, some eligible fleets could receive as much as $360,000 in total support for a truck priced at around $390,000. In certain situations, the available incentives can actually exceed the vehicle's purchase price. Now imagine a company operating a fleet of 20 diesel trucks at the Port of Oakland. California consistently has some of the highest diesel fuel prices in the country, making fuel one of the largest operating expenses for trucking companies. For busy fleets, annual fuel costs can easily reach hundreds of thousands of dollars and, in some cases, exceed $1 million each year. Switching to the Tesla Semi not only cuts energy expenses but also reduces maintenance costs while lowering the effective purchase price through generous state incentives. Because of this, many fleet operators are asking a different question today. Instead of wondering whether they can afford to switch to electric trucks, they're beginning to ask whether they can afford not to. Considering that 965 Tesla Semi incentive applications have already been submitted, it's clear many businesses have already reached that conclusion. So why are competitors finding it so difficult to keep up? Looking at today's market provides a clear answer. Traditional truck manufacturers still struggle to match Tesla's combination of battery technology, efficiency, and driving range. One of the strongest examples is battery utilization. Regulatory documents filed with the California Air Resources Board show that the long-range Tesla Semi uses an 822 kilowatt-hour battery while delivering an estimated driving range of around 500 miles at the maximum legal gross combination weight of 82,000 pounds. By comparison, the Freightliner e-Cascadia typically offers a range of up to 230 miles, while Volvo's VNR Electric is rated at roughly 275 miles in its current configuration. Although both trucks use battery packs larger than 500 kilowatt-hours, neither comes close to matching the Tesla Semi's long-haul capability. For freight companies, this difference matters because they don't buy trucks based on battery size alone. They buy productivity. A truck that can travel farther between charging stops can complete more deliveries and generate more revenue during a driver's shift. Every extra charging stop creates additional downtime, complicates route planning, and requires more charging infrastructure. Tesla's advantage extends well beyond driving range. The company designed the Semi around a fully integrated technology platform that includes its own battery cells, electric motors, power electronics, thermal management system, software, and charging network. Unlike many traditional manufacturers that converted existing diesel truck platforms into electric vehicles, Tesla engineered the Semi from the ground up as a purpose-built electric truck. This allows every component to work together for maximum efficiency instead of being limited by older vehicle designs. Charging technology is another area where Tesla continues to lead. The Tesla Semi supports charging speeds of up to 1.2 megawatts using the Megawatt Charging System standard. This enables drivers to recover a significant amount of driving range during mandatory rest breaks, helping keep trucks on the road with minimal downtime. Very few competing Class 8 electric trucks currently offer charging capabilities on a similar scale. Perhaps the strongest evidence of Tesla's position comes directly from the marketplace. Major logistics companies are no longer ordering just one or two demonstration vehicles. They're making substantial investments in electric trucking. Companies such as DHL, CEVA Logistics, Watt EV, and ArcBest have all expanded their electric truck programs, with several making the Tesla Semi a key part of their long-term strategy. The conversation across the trucking industry has also changed dramatically. Just a few years ago, people questioned whether an electric truck could handle demanding commercial freight. Today, the discussion is shifting toward whether competing manufacturers can catch up with what Tesla has already achieved. When an 822 kilowatt-hour battery pack delivers the kind of performance many believed would require an even larger battery, it shows that Tesla's biggest advantage isn't simply battery capacity, it's the efficiency of the entire vehicle working as one integrated system. That's exactly why so many fleet operators are paying close attention. For Tesla's competitors, the challenge is no longer just building an electric truck. The real challenge is creating one that can match Tesla's combination of long driving range, energy efficiency, ultra-fast charging, advanced software, and proven real-world productivity, all in a single package.